We are continuing with Z transform of elementary functions. So we know Z transform is a very useful transformation in image processing and digital communication system. And filter design. So image processing, right? We are doing all those things in in mobile, right? Mobile phone and everything. So these are all possible because of the Z transformation, and also we in the digital communication or digital sounds. So MP3, then MP4, then M4A, right? There are different types of sounds formats, right? And wave, WAV, FLAC, AALC. So all codes that format can be analyzed with the use of Z transformation, right? So next, prove that Z of a power n, which is equal to Z by Z minus a, where mod Z is greater than mod a. So given f of n is equal to a power n, we know f of n, which is equal to summation n is equal to 0 to infinite f of n Z power minus n. Z of a power n, which is equal to, replacing f of n by a power n, you will get summation n is equal to 0 to infinite a power n Z power minus n. So Z power minus n can be written as 1 by Z power n. Then a power n into 1 by Z power n can be grouped as a by Z power n. So we will get summation n is equal to 0 to infinite a by Z power n. Then substituting the value of n and expanding, you will get a by Z power 0 plus a by Z power 1 plus etc. etc. a by Z power 0, 1. So 1 plus a by Z plus a by Z square plus a by Z cube, etc. etc. This is like 1 plus x square plus etc. etc. The formula is 1 minus x power minus 1. Instead of x, you are having a by Z, so you will get 1 minus a by Z the whole power minus 1. So taking LCM, and you will get, so cross multiply 1 and Z, you will get Z minus a by Z whole power minus 1. Taking the reciprocal, so you will get Z by Z minus a, where given mod Z is greater than mod a. So therefore, so taking the reciprocal, the inequality will change. 1 by Z is less than 1 by mod a. So cross multiplying mod a into 1, so you will get mod a by Z is less than 1, right? So Z minus a by Z power minus 1, it will become Z by Z minus a. Next one. So you can use it as a formula. I already told you these are all the basic formulas. So when you are replacing a is equal to 1, so you will get Z power minus Z power 1 power n, Z of 1 power n. So Z by Z minus 1, a equal to minus 1. So Z of Z transformation of minus 1 power n, that's all, which is equal to Z by Z plus 1. You can put a is equal to 2, 3, 4, minus 2, minus 3, whatever it is. Z of e power an is a transformation. So this can be written as z of e power a whole power n. Instead of that particular 1, 2, 3, instead of a, you are having e power a. So replace that one. So you will get z by z minus e power. So the next one, prove that z of n, which is equal to z by z minus 1 square. Take f of n, which is equal to n. So we know z of f of n, which is equal to n is equal to summation n is equal to 0 to infinite f of n z power minus n. So replace f of n by n, you will get summation n is equal to 0 to infinite n z power minus n. Z power minus n again can be written as 1 by z power n. So you will get n into 1 by z power n. So this 1 by z whole power n is can be written as, right? So this, so doing the expansion, so put n is equal to 0, first term will become 0, second term 1 into 1 by x plus 2 into 1 by z square plus 3 into 1 by z cube. So this can be written as, so 1 by z plus 2 into 1 by z square plus 3 into 1 by z whole square. Taking 1 by z outside, so you will get 1 plus 2 into 1 by z plus 3 into 1 by z square plus etc. We know 1 plus 2x plus 3x square etc. is nothing but 1 minus x power minus 2. Instead of x you are having 1 by z, so this can be written as 1 by z into 1 minus 1 by z whole power minus 2. Taking LCM, so it will become 1 by z, z minus 1 by z whole power minus 2. Taking again reciprocal, so 1 by z, so minus will become plus z by z minus 1 square. So multiplying, taking the square to numerator and denominator separately, so you will get 1 by z, z square by z minus 1 the whole square. So z cancel, so z of n, which is the next one, prove that is should be greater than 1 by f of n, which is f of n is the power minus n. Replace f of n by 1 by n, so summation n is equal to 0 to infinite 1 by n is the power minus n. So taking z power minus n as 1 by z power n, so grouping all those things, we will get 1 by n, 1 by z power n in the summation. So here we are taking n is equal to 1 to infinity, because given n should be greater than 0. So starting from 1, right? Then taking that 1 by z whole power n to the numerator of n, so it will become 1 summation n is equal to 1 to infinite 1 by z whole power n by n. Now you substitute the values of n and take the series summation, right? So you will get 1 by z by 1 plus 1 by z square by 2 plus etc. So x plus x square by 2 plus x cube by 3 plus etc. is nothing but minus log 1 minus x. Instead of x you are having 1 by z, so it will get minus log 1 minus 1 by z. Taking a LCM inside the log, you will get minus log z minus 1 by z. This is equal to minus 1 into log z minus 1 by z. We know b log a. So whatever the number in front of logarithm can be written as the power of the a, logarithmic power, right? So b log a can be written as log a power b. Here you are having minus 1 instead of b, and instead of a you are having z minus 1 by z. So minus log z minus 1 by z can be written as log z minus 1 by z whole power minus 1. So taking again a reciprocal inside the logarithm, so you will get log z by z minus 1. Therefore z of 1 by n, which is equal to log z by z minus 1. Next one, prove that z of 1 by n factorial, which is equal to e power 1 by z. So again taking f of n, which is equal to 1 by n factorial, we know z of f of n, which is equal to summation n is equal to 0 to infinite f of n z power minus n. So f of n by 1 by n factorial, you will get summation n is equal to 0 to infinite 1 by n factorial z power minus n. So z power minus n can be written as 1 by z power n. Then grouping, so 1 by is equal to n is equal to 0 to infinite 1 by n factorial 1 by z whole power n. So taking 1 by z whole power n to the numerator of 1 by n factorial, so this can be written as 1 by z whole power n by n factorial, right? Substituting the values of the n, so you will get first one 1, because n factorial 0 factorial 1, 1 by z whole power 0 1. So first term 1. Second term 1 by z 1 factorial 1 by z square 2 factorial plus etc. 1 plus x square by 2 factorial plus x cube by 3 factorial is nothing but e power x. Instead of x you are having 1 by z, so this is e power 1 by z. That's all. Then factorial, right? Z of 1 by not n factorial. Thanks. We'll see in the next video.